Okay, so we're going to start our next topic, which is energy sources. One of these slides may be similar to a slide you'll see later. I did change the order of some of the information this year. So this slide you may see again, but we're going to go over it again anyway. So we started off our conversation on energy sources, talking about why do we need energy. And we came to the understanding that we use energy for everything. We use it for heat, we use it to give us light, to cook food, for transportation, to power technologies, power machines. So, I mean, we are heavily reliant on energy sources. We even talked about trying to get, jobs and thinking of the future, getting jobs in areas where you're being employed by an energy company, because we're never going to step back and use less energy. So it's a growing field. So we kind of looked at the importance of energy and the different ways we use it. We looked at where it comes from. One of the big things there we say is the sun. We get solar energy directly from the sun, but most of the other energy sources that we use do have some tie into the sun. So looking at fossil fuels, they would tie back into the sun. For instance, coal is a plant. Plants need solar energy and sunlight to help them grow. So without the sun, we wouldn't have coal, because the plants wouldn't have grown hundreds of millions of years ago to create that coal. So just to kind of look at some examples, even with wind energy, because the sun doesn't heat up the earth evenly, we get air moving across the surface of the earth, and that's wind. So the sun plays a role in just about every type of energy source that we use. And we really didn't talk too much in class about the goods and the bads, because we spend a lot of time going over that with each energy source, and we'll talk about the pros and cons of each energy source, and then we'll talk about the good and bad of renewables and non-renewables separately. So we'll spend a lot of time on that. So to get started here, we do a little introduction to electricity and kind of the human race, and how we kind of Morse code discovered instead of invented electricity. So I have here that electricity is an energy that occurs in nature, and it wasn't invented. It was just more discovered or found how to use to help human race. So we look at Ben Franklin. He gets a lot of credit for being one of these first people to kind of make this connection between lightning and electricity. And we talked a little bit about the bedtime story of him flying the kite with a key hanging off of it during a thunderstorm, and it got struck by lightning, and he started to realize that maybe this force of electricity could be used to power machines, or could be used in some way to help society out. Humans as a race have known that electricity existed for long before Ben Franklin. So even going back to the ancient Greeks in 600 BC, they discovered that rubbing fur on amber, which is like a fossilized tree resin, caused an attraction between the two. So the Greeks discovered was actually static electricity. Same thing when you walk across a carpeted floor and then you touch a doorknob and you get that little static shock. So the Greeks knew of this phenomena, but it just wasn't anything that they can harness or have in a useful way to kind of help them out. And we look at what amber is. Right here in this picture, this is John Hammond's from Jurassic Park, and on the end of his cane here is a piece of amber with the mosquito inside. So I kind of, just to show off what the amber kind of looks like, I used that image there. So after Franklin, which was in the late 1700s, we get Italian physicist Alessandro Volta discovered that a particular chemical reaction could produce electricity, and that was in the 1800s, or right around 1800. He discovered this and made it into a voltaic pile, which we look at now as kind of like a battery. Now, it was big, it was clunky, and it wasn't the most powerful battery, and not very, very portable, but it's a step in the right direction. And we also get the word volt from Volta. So it is a big contribution to the advancements of human understanding of electricity. And then we get into Michael Faraday. So in 1831, electricity became a viable use in technologies when Michael Faraday created what he called the electric dynamo, which essentially was a crude power generator. That's how we would look at that. Faraday's rather crude invention used a magnet that was moving inside a coil of copper wire, creating this tiny electrical currents that flowed through wires. And if we look here, we could see a picture of that. And that's kind of what his first generator, or dynamo as he called it, kind of looked like. He would go around and give these demonstrations to auditoriums or shows of people that would come to watch these scientists give these shows. And at the time, this was like magic. So he would do these different demonstrations with electricity and kind of show off this new technology. And we kind of looked into a little bit more of how that works, and we said even today with a lot of our power generators, they work in the same principle, where we need to have, you know, a coil of wires and some kind of magnet spinning around inside of them. We might have it on a different scale, and there's some tweaks, but a lot of what Faraday did is still used today to give us electricity. We might have different energy sources that we're burning, or whether it's nuclear energy or coal or a hydroelectric plant, to kind of turn the magnet inside the coil of wires, but it's the same general principle to get those turbines to produce that electricity that Faraday used, just on a different scale and a different size. After Faraday, we looked at Thomas Edison and the British inventor Swan. Each invented the incandescent filament, which is essentially the light bulb, in their respective countries, and that was again around the end of the 1800s. There, I have 1878. We talked about how the light bulb worked, where we had electricity going through a piece of wire, and then it got to a coil at the top, and as the electricity would heat up that metal coil, it would start to glow and give off light. Then we talked about the difference between direct current, or DC energy, and we compare that on the next slide to AC energy. But we have here Edison used his direct current system to provide and power the first street lamps in New York City in 1882. We have here with now Tesla coming in. Tesla actually worked for Edison and then eventually tried to sell Edison on this idea of alternating current, or AC, and that's what we use today. But Edison didn't like that idea, and Tesla ultimately broke off and teamed up with Westinghouse, and eventually down the road got bought out by GE. But we talked a little bit about that and how they kind of had the competition between Tesla and Edison, and eventually Tesla wins out with the alternating current, and that's what we use in our houses today. Direct current hasn't disappeared; it's still useful. It's, you know, still used for cars, and it's still used a lot of times in like chargers and things like that for batteries. But we ultimately use a lot more of what Tesla did. So that's where we got started, and the other videos are going to pick up with renewable and non-renewable energy sources. If you have any questions, feel free to stop by in class.